In this video, we're going to look at oxidation reduction reactions and learn how to determine what was oxidized and what was reduced. Okay, to begin with, oxidation reduction reactions are reactions that have a loss and a gain of electrons among the reactants. So one of the reactants is going to lose electrons, and that's oxidation, while the other is going to gain electrons, and that is known as reduction. And so one way to remember that is with the acronym Leo says GR. So Leo, my lion, says GR. Leo, and Leo stands for a loss of electrons is oxidation, says GR. GR is gain of electrons is reduction. And that is always true. Loss of electrons is oxidation, gain of electrons is reduction. And we're looking at what is being oxidized and what is being reduced. We're always talking about the reactants. One reactant is going to be oxidized, another reactant is going to be reduced in an oxidation reduction reaction. So one way to determine which reactant was oxidized and which was reduced is to look at oxidation numbers. Oxidation numbers are basically what charge that particular element has in its current state. And so elements that are in their elemental form have an oxidation number of 0 because they don't have a charge. They don't have an excess or a decrease of electrons. Ions, so ions that are either written by themselves with an ionic charge or ions that are in an ionic compound are going to have an oxidation number equal to their charge. For the purposes of this class, we're going to ignore polyatomic ions. They are going to be spectators ions in these oxidation reduction reactions that we will see. And so that means that you're going to see a polyatomic ion intact on both sides as a reactant and a product, and they are not taking part in the oxidation reduction reaction. So we'll just ignore them. Now, to determine what of your reactant was oxidized and what was reduced, we're going to look at those oxidation numbers and see what happens to them. So the reactant whose oxidation number increases when it becomes a product was oxidized, and the reactant whose oxidation number decreases when it becomes a product was reduced. Let's look at a few examples to see how this works out. Here's a reaction we're going to look at. Aluminum oxide decomposes to produce aluminum metal and oxygen. First thing we're going to do is go through and assign oxidation numbers. Aluminum oxide is an ionic compound, so the aluminum, the oxide in there are going to have oxidation numbers equal to their charge as an ion. Aluminum is a +3, oxide is a -2. You can look at your periodic table to find those. On the product side, we have aluminum metal all by itself, and so it is in its elemental form. It's going to have an oxidation number of 0. It's neutral. Oxygen is diatomic in its elemental form, and so it also has an oxidation number of 0. Now, to find out if aluminum was oxidized or reduced, we look at its charge, its oxidation number from the reactant side is a +3, and it went to, whoops, I don't know what happened to my arrow. Let's see, it went from a +3 to a 0. So its oxidation number was reduced. So we would say that aluminum, the aluminum ion there was reduced. The oxide ion in aluminum oxide went from a negative to a 0 oxidation number. And so it actually increased in oxidation. You can think of it as a number line, -2 being left of 0, and so it increased to get to 0. So the oxide ion was oxidized because its oxidation number increased. Let's look at another example. In this example, we have magnesium reacting with silver nitrate to form magnesium nitrate and silver. So first step is to assign oxidation numbers. Magnesium is by itself, not in a compound. It doesn't have a charge shown, so it's in its elemental form. It has an oxidation number of 0. Silver nitrate is an ionic compound. The silver is going to be a +1 charge. Nitrate is a polyatomic ion, so for the purposes of our class, we're just going to ignore it. It's going to be a spectator ion. Magnesium, over here in magnesium nitrate, has a +2 charge, and silver as a product is in its elemental state, and so it has an oxidation number of 0. So let's look at magnesium. What happens? It goes from a 0 to a +2. So that increased, its oxidation number increased, which means magnesium was oxidized. Okay, now the next one we're going to look at is silver. It went from a +1 to a 0, its oxidation number did. And so its oxidation number decreased. So that silver ion in silver nitrate was reduced. So remember, Leo says GR, loss of electrons is oxidation. So that means that magnesium lost electrons in this reaction. GR, gain of electrons, is reduction. So silver ion gained electrons in this reaction and went from a positive charge to a neutral charge. Okay, one last example. We have iron reacting with oxygen to produce iron 3 oxide. And so the first thing that we need to do is to assign oxidation numbers. Iron is by itself in its elemental form, so is oxygen. Over here in our iron oxide compound, if you may need to go through and look at what is the charge of the oxide, how many does it have to find the charge on iron. It has a +3 charge for this compound. Oxide is a -2. So let's see what happens. Iron goes from 0 to +3. Its oxidation number increased. So iron, we would say, was oxidized. It lost electrons. Oxygen went from a 0 to a -2. So its oxidation number was reduced. So it was reduced. Oxygen was reduced. So things to remember, make sure the first thing you do is to assign your oxidation numbers. Look at what happens from the reactant to the product and determine if it was oxidized or reduced from there. And remember that it's always the reactants that are being oxidized and reduced.